Okay, is everybody here that's going to be here? Yes or no? Yes? Excellent.
Dr. Henry, I had a student ask me a question. For the essay, can they go over the 2,000 word count?
Yes, but don't be crazy. If you go to 3,000 or 4,000 word count, then chances are it's going to be deducted against you.
Okay. So
I mean, if they go over by a little bit, 100, 200 maybe, but if you're, 500, 700, that's unacceptable.
Okay, got it. Thank you.
I'm not looking for a puff piece.
Dr. Henry?
Yes, ma'am.
For the presentation, does everybody from our group have to talk in the presentation?
Yes. And if they don't show up, then it's deducted against them. It's going to hurt them. It doesn't hurt the group if they don't show up, although the group should give them all an F, but I will give them an F completely. If you do not show up for the presentation, you're guaranteed an F. Any other questions? Okay, so let's have a quick discussion. I had a couple of emails this weekend that I weren't too pleased about. One was talking about the exams. You guys have been taking the same type of exam since the very beginning of the semester. So what do you think your exam is going to be consisting of, the third and the final? And if you don't know that by now, you may not deserve your degree. Anybody want to tell me? What is the format of your exams? So multiple choice and short answer, right?
Yeah. Show your work.
That's right. Show your work because you can use that to get some extra points. Right? Has that changed?
No.
It's been the same thing from the very beginning. So if you do not know that now, that probably means that you didn't take that first or the second or the third exam, right? So then that would be another set of issues. Okay. So secondly, you guys have 2 hours. Normally, these exams are based upon the exams that we would give you to show your competency in chemistry. And that is set up by the American American Chemical Society. They have a set of exams that we typically would give you. The problem is that those exams came in a little late, so I didn't give you those exams. Their exams have 65 questions that you have to complete in 75 minutes. Now, you guys get 2 hours. Typically, your exam consists of about 35 to 40 questions, depending on my mood, right? So I think you guys are getting over a little bit. 2 hours compared to 75 minutes. Okay, so if you've done your practice test and you've done it a couple of times, you know that you can do your practice test as many times as you want, up to 20, 25, 30, 100 times if you feel like it, right? And each time that you do it, your grade gets better, hopefully. And if it doesn't, then that probably means there's something else going on there. You guys do know that, right?
Yeah.
Okay, so if you're not doing the practice exam and you're failing the exam, that's probably a reason why you're failing the exam. It doesn't take a brain surgeon to figure that out. Now, if you're about the time with the exam, that probably means that you need to do the practice exam a little bit more, put a little more effort in. Okay, so my thing is, if you're going to complain about those things, right, you need to fix them. That's a problem that you need to take care of. Okay, this is something that has been going on before you started here. Okay, and again, this is the difference between a college course and a high school course. And if you can't step up to the challenge, then maybe you do not deserve the degree that you're working towards. I believe that you can, but you've got to show me you can. Instead of whining about things, start studying and working hard towards finishing. If you want this degree, it's yours. If you do not want it, I will gladly make sure you don't get it. Are we clear?
Yes. Yeah.
Good. So, a couple things we need to go over. Your last lab will be on Tuesday, if you're Avenel and Kalinga. Wednesday, if you're NDC. They have one lab left to do. My fault, I forgot the equipment. The third exam has to be completed by Wednesday. You need to make sure you have it completed by Wednesday unless you talk to me. Your practice exam, your practice final, I'm sorry, your practice final will open up on Tuesday morning. Make sure you guys do your practice final over and over and over and over again. You have a couple of days to sit there and get it done. Your final will open up on Wednesday. It's technically, get this again, technically it is due at 11:59 on Friday. However, because I'm behind on grading, it won't close until Sunday, right? Since I don't get a chance to look at it until Sunday, if you get it done before Sunday, you're good to go. Are you understanding what I'm saying? But officially, because your class ends at 11:59 p.m. on Friday, it technically ends there. You guys understand what I'm saying here? Okay. So all your lab reports, your homeworks, all of that stuff needs to be completed by 11:59 p.m. on Friday. Again, I probably won't get to them until Sunday. So I will accidentally leave them open. So make sure you're turning your stuff in. This is the only opportunity that you guys are going to get to do this. Are you clear? Do you understand what I'm saying?
Yeah.
What was that, Alicia?
Could you say that one more time, actually? I didn't really hear it.
You want me to repeat it, what I said?
Yeah, please.
Yes, I said officially, because your class ends on Friday at 11:59 p.m., it's going to say it's due at 11:59 p.m., but it's going to accidentally stay open until Sunday. Okay, so you'll have until Sunday to get all your last bit of work in.
All right, thank you, Mr. Henry. Dr. Henry.
Okay?
Wait, Dr. Henry,
Yes.
what about the test corrections? Where do we submit those?
There will be a spot on Canvas that says all test corrections, right? That's where you're going to submit it.
Okay, and when is that due, on Friday as well?
Technically, it's due at 11:59 p.m. on Friday. I won't get to test corrections until Sunday. That is a
Okay.
guarantee. That is the last thing that
I'm
I
hearing
grade.
from students that it is locked.
It is locked. I will make sure that it's unlocked for you guys.
Okay, thank you.
Okay.
We only have one test correction, right?
Yes, you only have one test correction. So
Okay,
use it
thank you.
wisely. I should have your second exam graded by tonight. And hopefully for those who've already started to do their third exam, I will have those graded as soon as they're starting to come in. Okay. Okay, so the last thing is your presentation. So you guys should have gotten a doodle or a noodle or something like that. Did you guys get something from me? An email with the noodle link? Yes, no, maybe? About signing up for your presentations? Yes, no. Okay, so anyway, I sent you an email. It basically sends you a link to sign up for your presentation. Make sure you guys sign up for your presentations. If you're not signed up for your presentations, that means you're not doing your presentation. If you don't do your presentation, you get a 0 for it. So it kind of defeats the purpose, right? So make sure you're signing up so that we'll know the schedule. Now, once everybody signs up, I'll send you guys a list of the schedule so that you guys remember the time that your group is supposed to go. Now, one person in your group, each group should have signed up. Okay? Are we clear?
Yes.
Okay, so make sure you guys sign up. So you need to make sure that you're there to present. You want to be there at least 5 minutes before the time that you're supposed to present. Even though I may not be on time, you need to be on time, okay? So the other thing is,
Let me get the shirt. Just type it in the chat.
the other thing is that you guys want to make sure that, you know, you're at a place that you have a stable connection, right? If you do not have a stable connection, let me know, and we will try to get some rooms opened up in Coalinga so that you guys can go to Coalinga. And then Avenel is technically open the whole time. So we will try to make sure that we have somebody there so that you guys are able to come in the room and use the facilities on campus so you'll be able to do your presentations. Now, do you guys remember what I said about the questions? Margarita remembers everything. Margarita, can you help me out? Tell me, what did I say about questions? So, because remember, there's a question and answer session part of your presentation.
Yeah. What about
Yeah.
that?
So what did I say about that? So if you guys don't ask questions, what happens?
Oh yeah, you will start asking questions.
Yes. And then my questions will be typically a lot harder than the questions that you guys ask, right?
Yeah, correct.
So you want to make sure that you are there to help support your classmates and ask them questions. Is that correct?
Yes.
Okay.
Yes.
Good. Good. So you want to try to make other people's presentation, you know? So it could be a long day. So, but it pays off in the end. And plus, if you catch, let's say you sign up for the last presentation, you have a good idea of what not to do based upon some of your classmates' presentations, right? You learn
Correct.
from other people's mistakes. Isn't that right, Nicole? Okay, good. Okay, let's see.
Can we do a Kahoot?
Can you do a Kahoot? Oh
Yeah,
yeah,
so we can-
actually you're saying, yeah, I actually, long as it doesn't take the whole time, if it's like 2 minutes or 3 minutes, yes, you can do a Kahoot.
Like instead of the questions could be like from the Kahoot.
No, that doesn't qualify for the questions, no.
Oh, okay.
Yeah, because then you're feeding them the questions. I don't want you to feed them the questions. Do you understand the difference?
Yeah, I do.
Yes. Okay, so someone had asked me about, can I do a test correction on an exam I didn't take? No, you can't do a test correction on an exam you didn't take. Exam that you didn't take would be considered a 0. If you have not taken an exam, you need to come talk to me, or you've already come talk to me, and we need to make arrangements to make sure that you have taken all the exams.
Oh, and another question from an anonymous student.
Anonymous, yes.
Even if we all present, do we have to watch other people's presentation?
As I say, you don't have to do, you're grown, you don't have to do anything, right? So you're not required to watch anybody else's presentations, but it is to your benefit because, you know, you want to help out your colleagues, right?
Yeah.
You guys are in it together, in it to win it, right? So,
Yeah.
I have a quick question, Dr. Henry. So as far as the presentation, are they like in person, or is this over Zoom, or what's exactly the form?
The format is going to be via Zoom, because currently we got to get used to using Zoom. We got to get used to using telecommunications type of instrumentation. So I think it's a great opportunity for you guys to sit there and present via Zoom. Now, again, if you're having trouble, if you have trouble with your internet connection at home, we will set up a classroom so that you'll be able to be in the classroom. And so the idea is that each of your members should be able to Zoom in and then present their part via Zoom.
Okay, so on Zoom, like each member get on there, sign in, and then I'm kind of lost.
Okay, so the way it would work, let's say me, you, and Margarita were a teammate, right? And
Okay.
I'm in Hanford, you're in Coalinga, and Margarita is in Avenel. So we're all logged into Zoom. So when we're ready to present, we're going to be pinned on the board, meaning that we'll be set up so that we're the main topics, right? One of us, let's say I'm better at controlling the presentations. One of us will control the presentation. The person who has the most stable network should be the one that controls the presentation. So I will click the slides. So then as I'm clicking the slides, you go ahead and talk. You talk and say, and then you'll say next slide. I'll hit next slide. You keep talking and tell me about the whole story that you're telling me about, hit next slide, right? And then when it's Margarita's turn, then Margarita starts talking. Do you understand?
Yeah, but then what about the whole video? Like,
Excellent. So the video should be the last thing that you present. So you could either embed it in your presentation so that all you have to do is click on your presentation and it takes you to your YouTube and then you show the video, right? So your presentation you give first and then we finish off with the video.
Oh, wait, we have to post a video on YouTube?
Yes, I would put it on YouTube. That's what I would do if you're me.
Oh,
Or you could
okay.
put it on your Google Drive, right? So, but you want a copy somewhere so that I have access to it and so that you guys have access to it. And you want it so that everybody in your group has access to it. So let me tell you some traumatic events that have happened in the past. I had a case where we had a team that basically had worked throughout the whole semester, and they actually were pretty good at working. They meet consistently and everything like that. One of their members ended up contracting COVID, and she had access to the video and nobody else did. So at the very last minute, they had to recreate their entire video. And I'm not kidding when I say the very last minute, because nobody knew that she had COVID. Nobody knew this. That wasn't the reason why she wasn't showing up. So,
Right.
So you want to make sure that there are a couple of copies going around, you know, and the best way of doing that is by putting it on YouTube and giving public access, or at least access to all of your cohorts that are in your group, your colleagues that are in your group, not your cohort.
Okay, another question from an anonymous student. So they asked if they could make their presentation interactive, like kind of like a teaching style type of way. Like they ask the audience a question.
It is your presentation. You are free to do it that way. And sometimes that is very effective, and sometimes it isn't. But yeah, it's your choice.
Okay.
Okay, let's see. Any other questions?
All the videos don't count.
Question in the chat.
Can you repeat that, please?
There's a question in the chat.
I think I just answered a question in the chat.
You sure? Can you say it one more time, please?
Did you want me to answer it one more time?
Oh, never mind. Hi, just look. I'm just kidding.
Okay.
I'll ask you later.
Okay, so now as a recap, if by chance, and I know that this is a very low probability because I know that you guys are going to be working your butts off this last week like maniacs, but if there is a small probability that you do not do very well on the final, what you're going to have to do is, well, you could take the grade that you get, or you have the option of taking the final next week, okay? Now, if you take the final next week, right? So again, it'll be a different exam than you had before. So you'll have the opportunity to study and I'll open up some practice exams so you can get the practice in, but you have to get it done by Wednesday, right? It has to be done by Wednesday because I have to get, particularly for Avenel, your grades are due at Wednesday at 11:59 p.m. for me, right? So it has to be done by 5:00 p.m. on Wednesday, okay? Now, but you also need to contact me and let me know that you're retaking the exam, because if I don't know that you're retaking the exam, I'm just going to assume that you're happy with the grade that you got, and I'm going to give you that grade, okay? So you need to communicate like an adult. I don't want to hear it from Mrs. Gornick or Mr. Ruiz or Mrs. Cantoon. I want to hear it from you, okay?
When are you adding the extra credit from tutoring?
I will be adding all of the extra credit at the very end on Sunday when I start to finish grading. So you won't know anything until the very end because I want you to work your butt off to make sure that you get the A that you deserve.
Okay, thank you.
You're welcome. Okay. Questions? Any other
Yes,
questions?
I have a question. So as far as the exam goes, okay, so the exam 3 is due on Wednesday, and then what about exam 4?
So exam 4 and your final are going to be the same, okay?
Oh,
so your
okay.
final is going to count as exam 4. So that's why I'm also giving you that option of taking the other exam. So it will, the final basically will supersede your exam if you do well on it, right? If you don't do well on it, it still will supersede your exam, okay? So then you'll have another chance to do it next week, okay?
Oh, next week, okay.
Yeah. So, but it'll be the same exam. Well, not the same exam. It'll be the same type of exam, same format, same number of questions. You'll just get another opportunity to take it. Okay.
Yes.
Okay. Any other questions? Good. Okay, so let's get started. We have a lot to cover. Okay, last we left off, we were talking about percent composition. So percent composition is really not too complicated. It's just thinking about the part over the whole. Okay, so if we're talking about a chemical compound, like we were talking about in the case of calcium fluoride, so we're looking at just the fluoride in calcium fluoride. Okay, so do you guys remember that process? So if we have a chemical compound, let's say that we have,
Guys, quiet down, please.
let's say we have sodium sulfate.
If everyone quiets down, yes.
So if I have sodium sulfate and I want to know the percent, what percent mass of sodium is in sodium sulfate? Okay, so how would I go about this?
You look at the math that it has.
Okay, we'll look up the mass that it has. So tell me. So first off, shouldn't I probably know the chemical formula for sodium sulfate?
Yes.
Okay, so what is the chemical formula for sodium sulfate?
It is Na.
Na.
SO4.
SO4. Okay, what is the charge on sulfate?
Sulfate is -2.
It's -2. And what is the charge on sodium?
Yeah,
It's positive. So how many sodiums am I going to need?
2.
2. Okay, so that's the chemical formula for sodium sulfate. So now you tell me I look up the mass. I should probably know how much of each one I have. How many sodiums do I have?
For Na is 23.
So it's 23. So 23 times 2.
Is 46.
Okay, how many sulfurs do I have?
We have 1.
I have 1 sulfur. So how much does sulfur weigh?
1. Oh,
How
wait,
much does it weigh?
2.
32.
Yeah.
And how many oxygens do I have?
4.
Okay, and oxygen weighs?
16.
So if we do that math, so totally it weighs 142 grams. So then what would I do to calculate the percent mass of sodium?
What?
So what would I do to calculate the percent mass of sodium?
Oh, you multiply it by 100%.
I multiply what by 100%?
Sodium.
The sodium? So the sodium weighs how much?
46.
46. And the total?
142.
142. So 46 over 142, the part over the whole. And what do you guys get? 32.4%. Okay, piece of cake. Okay, let's see how we can use it. Calculate the percent composition by mass of aluminum sulfate. So what is the chemical formula for aluminum sulfate?
AlSO4.
Is that neutralized?
No.
No, because we know that SO4 has a -2 charge, and then Al has a what charge?
A 3 plus.
A 3+. Okay, so how many of the ALs do I need to have to balance out the number of SO4s that I need to have?
Don't you have to multiply the 3 and 2?
So you said 2, and then the SO4 by what?
You guys, quiet down, please.
A 2?
By 2 as well?
What was the question?
What should be the subscript for the SO4?
3.
Okay, so I'll need 3 of these. So 3 times -2 would be a -6. And then 2 times 3 would be a 6. 6 minus 6 is 0. That works out. Okay, so we know that that's balanced now, right? So how do I calculate the percent mass of each of the components of sodium, of aluminum sulfate?
So you have to find the mass of each.
Okay, so what is the mass of aluminum? And how much aluminum do we have?
2 times 27.
I heard something that we have 2 aluminums. So 2 times, you said 27? Is that correct?
Yeah.
Okay. And how much sulfur do I have?
3.
I have 3. So that's 3 times 32. And how many oxygens do I have?
12.
12. 12 times 16. So this is 54. 3 times 32. And 12 times, Fatima, 12 times 16. Fatima, what is 12 times 16?
$192.
192. Man, Margarita, I could have sworn. I said I could have sworn. Are you like everybody in the class? Because that's all I hear. I hear Margarita. That's it.
Oh, Leanne that says this right now.
Oh, that was Leanne? My bad. Okay, so we add it together. What are we getting?
My bad, it was Ashley.
What was that?
It was Ashley, my bad.
It was Ashley? Okay. 23. So 342. Is that what you guys got?
Yes.
Okay. So if we're looking at aluminum, percent aluminum. So how would I calculate the percent aluminum?
You put 54 over 342 times 100.
So 54 over 342 times 100. Okay.
That is 15.8.
15.8. Is that what I heard? Okay, is that correct?
Yeah.
Okay. So what about sulfur?
So 96 over 342.
96 over 342 times 100.
Equals 28.1.
Good. Okay, and then the oxygen?
192 divided by 342.
Divided by 342 times 100.
That equals 56.1.
So you said 56.1. Okay, piece of cake? Yes, no, maybe? Good. Okay, let's move forward. Okay. Aluminum chlorate is 38.35% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? Okay, so how am I going to set this guy up?
Write down what you have.
Okay, so I'm giving my percent mass in terms of chloride. And it says, what source of 50.0 milligrams of chloride? So what is the mass of aluminum chlorate is needed as a source? So if I have, this is my chloride. So if I had 50.0 milligrams of chloride, how much of X times 100 will equal this? So what do I need to do? Let's not use X, let's use Z. How much of Z meaning the aluminum chlorate, will I need?
You multiply 50.0 or not?
I multiply 50.0. How about I multiply both sides by Z to get rid of the Z and to get the Z by itself? So if I multiply this side by Z and this side by Z, right? So then Z's are going to cancel out. And then I'm left with Z over here. And then I divide both sides by 38 point. So if I divide both sides by 38.35%, so then this is going to cancel out. And then I'm left with Z equals 50.0 milligrams divided by 38.35%. Stay consistent. Times 100%. So my percents are going to cancel out. And I'm left with what? $130. So how many sig figs should I have? I should have 3 sig figs. So 100 and so we'll say 1.31 times 10 to the second power milligrams. Okay, it's good. Eric? Is that clear? Okay, good. Okay, let's see. Okay, so let's talk about empirical formulas. Okay, so the empirical formula is the simplest form that we can get to. So what I mean is basically I need to find the lowest integral ratio between the two different elements. So for instance, if I have C2H2 is 2 the lowest integral form that I can have of these two? Or can I divide it by something and still have a whole integer left? Are you guys with me?
Yes.
Is there a number that I can divide both the C and the H into and still have a whole integer left? 2. So if I divide both of these by 2, I would get CH. So then that would be my empirical formula. Okay. So the empirical formula is the simplest form of that compound that is the lowest integer possible. Okay. So if I have C4H10, what would be the empirical formula for this guy?
2 and 5.
2 and a 5. So it'll be C2H5. Because I can't divide it by anything else and have a whole number, right? Okay, so that is your empirical formula, okay? Now, the empirical formula, we will often use the empirical formula as means to give us an idea. So typically, if we're doing some type of analytical analysis, we always get numbers based upon ratios to each other. And so it gives us the lowest integer typically when we're looking at an analytical instrumentation. It will give us our empirical formula. And then sometimes what we'll do is figure out from that empirical formula, we'd have to figure out the full molar mass of the compound. So, but we'd first have to figure out the molar mass of the empirical formula. How will I determine the molar mass of C2H5? What is molar mass again? Let me type that out. What was that? The weight, exactly. So what would be the weight of C2H5? Carbon weighs how much?
12.
Okay. How many carbons do we have? 2. So 2 times 12.
24.
Okay. And then how many hydrogens do I have?
1. Oh,
How many?
5.
5. So 5 times 1.
5.
Okay, so then it's going to equal
29.
29.
So that's the molar mass.
So that would be the molar mass of the empirical formula. Now, if we want it of the molecular formula, this is the molecular formula. So then we know that we divided this by 2. So if I just multiply this by 2, that would give me the molar mass of the molecular formula. Does that make sense? Yes, no, maybe? So this would be the molar mass of the empirical formula. Or so this would be the molar mass of the empirical formula. And so to figure out the molar mass of the molecular formula, all we'd have to do is multiply this by 2, since we know that that's the integer that we divided everything by. Or we could do it the long way and just calculate it 4 times 12 and 1 times 10. Or we could just multiply that guy by 2 and we'll end up with just our 58 grams per mole. Okay. Simple. Now, why is this important? Okay, so this becomes important again when we're trying to do analysis, analytical analysis, because typically instrumentation doesn't tell us the molar mass. It'll tell us relative to each other how much you have of certain things. And because of that, we will always end up with getting the empirical formula. Okay, so let me give you an example. A sample of a pure compound is made up of 1.61 grams of phosphorus and 2.998 grams of fluorine. Find the empirical formula of this compound. So the first thing that we want to do is we want to compare quantity to quantity, not mass to mass. Okay, because if you take a look at this, we're comparing that 2 to 5, right? When we had done it earlier. So you're comparing how many you have to each other. So how do I get from mass to quantity? Anybody want to take a guess? Okay, we'll put 2 points on the line. I have 2 extra credit points to go to the first person that tells me the correct way from going from mass to quantity. What am I going to use? Put it in the chat. Or if you're in Avenel, tell Mrs. Inez and she'll put it in the chat. 2 points. What was that? Okay, Mrs. Inez, can you repeat what they said?
Grams over milliliters.
Grams over milliliters? So that would give me density, right? So would that change mass into quantity, or would that change mass into volume? Because milliliters is volume. But it was a good attempt though. Anyone else? 2 points. Got 5 seconds. Give me an answer. 5, 4, 3, 2, 1, 0. Okay. So nobody wanted 2 points, huh? Who was that gave me that attempt?
Was Ashley.
That was Ashley. So Ashley, I'm going to give you a point just for making the attempt and being bold enough to say something. So Miss Inez, can you do me a favor? Keep record of that for me because you know I'm old and I forget everything.
Sounds good. I'm old too, and I forget everything.
Okay, so I'm going to help you guys out here, right? But we've talked about this. The way that we change mass into quantity is that we use molar mass. Moles is quantity, right? So 1.61 grams of phosphorus. Chemical symbol for phosphorus is P, is that correct? So what is the molar mass of, or the atomic mass of phosphorus?
That's 30.974.
30.974. Can I say 31 because I'm lazy?
Yes.
Okay, so that's 31 grams, because I want to get rid of grams and I want to change it to moles over 1 mole. Of phosphorus. So grams are going to cancel out, and then I'll be left with moles. So what is 1.61 divided by 31? How many sig figs should I have for my answer?
3.
Okay. Okay, so if I'm starting out with what I'm given, so, and the chemical symbol for fluorine is what?
F.
F. Okay, fluorine. What is the molar mass of fluorine or the atomic mass of fluorine?
19.
19 grams. 1 mole of F. Grams are going to cancel out. How many significant figures should I have?
3.
Okay, so in this case, because I want ratios, whole integer ratios, I want to do my best to try to get these guys to whole integers. So what I'm going to do is divide it by the smallest number between the two. Okay, so which is smaller, 0.0519 or 0.157?
I don't know how to take that out.
Which number is smaller?
0.0519.
Okay. 0.0519. So I divide this by itself, and then I also divide this number by the same. Okay, so then this guy is going to give me 1 P. And then this guy is going to give me
Could you lights?
If everyone quiets down, yes.
Pardon?
If everyone quiets down, yes. You can turn off the lights.
so This guy's going to give me 1 exactly. This guy's going to give me 3.02, which is close enough to 3 that we can just say it's 3. So if I look at the ratio, this guy's for every 1 phosphorus, I have 3 fluorines. So then that gives me the empirical formula for this compound. Do you guys get that? So the first thing that I need to do, if it's in grams, I need to convert it into moles, right? Because moles is quantity. That allows me to sit there and look at numbers compared to each other, right? Those whole number ratios. Then the next thing I do is divide it by that smallest number, both of the numbers by the smallest number, and then that should give me an empirical formula. Okay, are you with me? Feeling confident, or do you want to try another?
Another.
Try another, okay? Okay, so here, I'm going to try another. We're going to make it a little more complicated. So here we have percent mass of carbon in nicotine, of hydrogen in nicotine, and of nitrogen in nicotine. Okay, so percent mass is percent mass, right? So the one thing that we can do is, if we know that it's percent mass, we can make an assumption that we have 100 grams of nicotine. So if I have 100 grams of nicotine, how many grams of it is going to be carbon?
Can you repeat the question?
I said, if I have 100 grams of nicotine, how many grams of it is going to be carbon?
8.64%.
Can you repeat that again?
8.64%.
Okay, if I have 100 grams of nicotine, how many grams of it is going to be carbon?
4.1.
Okay, so if I assume that I have 100 grams of nicotine, then 74.1 grams is going to be carbon. How much of it is going to be hydrogen?
8.64%.
8.64%. Or 8.64 grams, right? And then how many of it is going to be nitrogen? 17.3.
I did put decimal on carbon.
What was that, Alicio?
They go the decimal for carbon.
You don't see my decimal? Is that better?
Yeah.
What are you eating, Dr. Henry?
What chocolate bar? I eat when I stress. You guys make me stress.
We're stressing. You're stressing us.
Yes, I'm a stress eater. Okay, so how much does carbon weigh?
Wow.
12. So I know that that's 12 grams for 1 mole, right? I want to get rid of grams, so I'm going to put that on the bottom. I put 1 mole on top. Okay, so what am I going to do with the hydrogen?
You're gonna
It stays the same. So 8.64.
So it stays the same because I know that I have for every 1 mole, it weighs 1 gram. So 1 mole of hydrogen weighs 1 gram. But I'm going to put it up here so we don't think that I neglected hydrogen.
for nitrogen, you're gonna basically divide it by 14. I give it a mole.
So we need to divide it by how much, Alicio?
14.
14?
Yeah, then you're gonna mole too.
And you put my mole up top. That's right.
Is it 1.23?
1.24 moles. Okay. So what do I do next?
You divide it by the lowest.
Divided by the smallest. What is the lowest number?
1.24.
1.24. Okay. So if we look at this number 4.98, that's pretty darn close to 5. So we have 5 carbons. How many hydrogens? And how many nitrogens? Okay. Piece of cake.
Yep.
Okay. Okay, so when we're finding the molecular formula, were you guys ready for me to move on, or did I just get ahead of myself? Questions, concerns, Cash? Okay. Okay, so when we're finding the molecular formula, we need to have the empirical formula or be able to calculate the empirical formula. And they have to give us a little bit information about the molecule itself. Okay, either the molar mass of the of the molecular formula or something along those lines. Okay, so let me give you an example. A compound with an empirical formula C2H5 has a molar mass of 58.12. So that means that the molecular formula has that molar mass, because we know the empirical formula is smaller than that, right? So it says find the molecular formula for the compound. So the way that we would do that is, what is the molar mass of the empirical formula? How would I calculate that?
Find the mass of the element.
Okay, so how many carbons do I have in my empirical formula?
2.
I have 2 carbons. 2 times 12.
24.
So somebody said I have 5 hydrogens. 5 times 1. So 24 plus 5. So if the molecular formula weighs 58.112 grams per mole, and the empirical formula weighs 29 grams per mole. So if I go 58, I'm sorry, 8, and I divide it by my empirical formula, which is 29. So that's going to be about 2. Is that correct? Or am I making stuff up? So then I would multiply my empirical formula by 2. So piece of cake? Steven, piece of cake? Georgina? Okay, moving on. Chapter 9. Oops. Okay. Okay, so one way that we can determine whether or not certain things are able to conduct electricity is by basically using the light bulb conductivity apparatus. So basically, the way a light bulb basically works is that it has 2 electrodes. These electrodes, if they're connected, then they're able to sit there and allow the electrons to travel through the metal. And so then you form a complete circuit and you get light. If you disrupt that circuit, like you put a resistor or something like that in between, or a switch, so that allows it, one case it's separated, but when the switch is turned on, it closes, then you get light in that case when it's closed, but when it's open, when they're separated, you don't get light. Okay, you see how this works? Yes, no, maybe? Okay, good. So now certain solutions are able to conduct electricity. So those solutions will typically form ions when they're in solution. So if you don't form an ion, let's say in the case of ethanol, ethanol stays complete, it stays whole, it doesn't separate into an ionic component. It's covalently bonded, there's no ions. Because there are no ions, it won't conduct electricity. So you won't get any light, okay? Now, if I have a strong electrode, like a salt, so in this case, we're using copper 2 chloride. So copper is 2+, chloride is is minus. When they go in solution, when we put them in solution, they dissolve in solution into their ionic components. So you'll have copper 2+, and you have chlorine minus in solution. Because you're getting that plus and that minus in solution, it allows the solution to conduct electricity. It'll orient those charges so that the electron is skipping from each of those different elements to the other electrode. Are you with me? Okay. Now, if you have a weak electrode, like a weak acid, like acetic acid, vinegar, right? The majority of vinegar is going to be in its acid form, connected, right? Where the hydrogen is connected to it. But there are going to be a few, only a few of them, that are going to dissociate into its ionic forms, where you have the acetate ion and the hydronium ion. Okay, so because it's a weak acid, you're only going to have a few charges in solution. Most of them are going to act as if it's kind of like covalent. In other words, it's not going to separate into its ionic compound. Okay, because it's not going to separate into its ionic compounds, but you have a few that do separate, you're going to have a weak light signal. Does that make sense?
Yeah.
Okay, so weak acids or weak electrolytes conduct electricity poorly. So they're always going to give us a weak light signal if they're trying to conduct electricity in this manner. Where strong electrolytes, they conduct electricity very well. And so you're going to get a really bright signal in that case. Okay? So an electrolyte is basically the formation of ions. So how many of you guys drink Gatorade or pH water or let's see, what is it, Body Armor, or what is the other thing? Powerade. Any of you guys drink any of those things? No? Do you guys drink purified water? Anyone?
No.
You don't drink purified water? You mean the water that you guys get from the bottled water?
Oh, yeah, we do.
Okay. So about bottled water, right? If you look on the back of your bottled water, how many of you guys have a bottled water in front of you? Anyone? I believe it says, on most of them, it says enhance with minerals for taste. Do you guys have that one? Does it say it's enhanced with minerals?
Dr.
Or, yes.
Do you think all water tastes the same?
No, not all water tastes the same. So I can bring you guys some Hanford water, and then that'll prove everything. And although it's a lot better than what it used to be.
Didn't we use baby water, like the water that babies drink, and one of our labs?
Distilled water. So yeah. So distilled, yes, you guys use distilled water. Yes. Yeah. So in the case of water is going to be slightly different everywhere depending on its source, right? Because your water source is typically, let's say, for instance, a lot of the water that we get in California comes from the aqueduct, right? So the aqueduct is coming from the mountains, and the mountains are typically mineral rich. So it has a lot of minerals in it. Certain areas like Hanford, we also get our water from the aqueduct, but it goes through another source to get here, right? As it goes to that other source, it would actually put in a lot of sulfur in the water. And so Hanford water used to smell like rotten eggs back in the day. It doesn't anymore, but it used to, right? Have you ever smelled rotten eggs?
Yes, that's not bad.
Yeah. And the water used to have that taste too. So you could taste the sulfur in the water, right? And so in that case, it was very mineral rich with sulfur in it, right? So most water that you get has minerals in it, right? They often will have carbonate, it'll be calcium chloride, sodium bicarbonate, magnesium sulfate, right? So some of the same chemicals that you guys are using and that you have used in the lab. right? But in very, very small quantities, right? Because too much of anything is bad, right? Okay, so that brings us to these electrolytes and conductivity. So electrodes are basically the conductors that allows those electrons to enter and leave. Okay, so those electrolytes or the electrons are able to sit there and enter and leave. The electrical charges are able to enter and leave to the electrolytes. Electrolysis is the process of using electricity of doing this, right? Or the passage of electronic charge through the electrolytes. Like for instance, DNA. DNA has a negative charge associated with it, right? Because DNA has a negative charge associated with it, we could actually put electrolytes in solution and we can separate DNA based upon size, how big it is, because the bigger it is, the more negative charges it's going to have. The smaller it is, the less negative charges it's going to have. Okay. Okay, so here's an example. This here we have potassium chloride. So we put potassium chloride in solution, and as soon as we put in solution, it dissolves. The water is going to surround both the potassium ion and the chlorine ion. The hydrogens are going to be oriented towards the chlorine ion, because hydrogen is going to have that partially positive charge and chlorine is going to be negative, so it's going to orient it that way. And then the oxygen is going to orient towards the potassium because it is partially positive and oxygen is partially negative. So all of the oxygen is going to be facing towards the chlorine ion, and then, all of the oxygen are going to be facing towards the potassium ion, and all of the hydrogens are going to be facing towards the chlorine ion. Okay. So this gives you an idea of what happens. And so as the electrons go through, it's going to cause an orientation. The positive is going to go towards that negative electrode, and the negative is going to go towards the positive electrode. And it's going to act kind of like a bridge to sit there and allow the electrons to be carried through. Okay, so you're going to get a circuit forming because of it. Does that make sense? Yes, no, maybe? Okay, so strong electrolytes, they're going to be able to conduct electricity, and they're going to be almost completely ionized, meaning they're dissolved. They're almost completely dissolved into their ionic forms. A weak electrolyte is only going to have a little bit dissolved or ionized, okay? And a non-electrolyte won't have any ions in it. Okay, so when we talk about our solutions, remember we often will use aqueous, right? When we put stuff in water. So if we put sodium chloride, salt in water, we break it up immediately into the sodium ion and the chlorine ion. So if I just put a little bit of salt in a whole bunch of water, what happens? Does it stay around? If I stir it a little bit? No, what happens to it? It separates. It separates into its ion. It dissolves, right? So you basically go from that salt pellet that you put in there initially. As you stir it a little bit, you don't see any more of it because it dissociated into its ionic components. So then in that case, we're getting that sodium plus and that chlorine minus, right? Which they're really cool like that. They're happy like that. They're like, that works, okay? It's a stable form because they got that charge that they needed to be like the ionic compound that they want, or to be like the noble gas that they wanted. Okay, now the same thing is going to happen with copper 2 chloride, right? As soon as we put copper 2 chloride into water, it's going to dissociate into its ionic compound. okay? So again, this is basically what happens. This is the salt as we put it in, so it's all clumped together. But as we sit there and we stir it up a little bit, we separate it into its ion components, the sodium ion and the chlorine ion.
Guys, quiet.
Sodium,
Still not done with lecture.
what was that?
Oh no, it's because you're still not done with lecture. They were just talking.
Oh, they're getting anxious because they have 3 minutes. Tell them I take every 3 minutes and I'll take a little extra. So this plus here, right? So that's our sodium. It's going to have a plus charge associated when it's in solution. The chlorine is going to have that negative charge associated with when it's in solution, and water is acting like that home record that's splitting them up and keeping them separated. So long as we have enough water, we can keep it separated. But we can get to the point where we add so much salt and not enough water that we're not able to separate all of the ions. Okay, are you with me? And that's kind of what you're seeing over here. It all comes together. Okay. So here, the same thing happens with the copper 2 chloride. As soon as we stick it in solution, the copper 2 chloride will separate. Okay, as long as we don't add too much that we outcompete the water. Okay, so we're going to stop here. This is a great stopping point.